Hello everyone, welcome back. So, let's try an example with some wedges. So what do we have here? Well, we have a 3,000 pound load being applied to B, and we have some force P right here. And what we want to know is, well, what's the smallest force P needed to lift the 3,000 pound load? So, first off, plan. Draw free body diagrams. And apply your equations of equilibrium to both of these. Why B first? I'll let you figure it out. Now, one other thing I want to talk about is the following. What direction is motion impending? What direction is motion impending? This is the last little hint I'm going to give you for this problem. I'm applying a force P to lift B, which means that A is going to have to move in what direction? Well, it's going to move in the same direction as the force P. And so friction is going to be resisting it. Okay, that's a little bit of help for your free body diagram in A. I'll go from there. So, in 3, 2, 1. Okay, you've paused. You've tried the problem on your own. You got stuck. You asked a friend. You asked your dog. Your dog was surprisingly helpful. And you came back and you rocked it. Or you didn't. Either way, that's fine. So, let's do this problem together. Now, first, like we said, we have to have some free body diagrams. And let's look at each of these little points to figure out where they came from. Well, right here we see we have a 15-degree angle from our wedge. That's good, we know about this. This is the bottom wedge, the one we're applying the force to lift our 3,000 pound load. Now, due to similar triangles, we know that this one right here is also going to be 15 degrees between the vertical axis and this angle. That's really easy to see here because it just seems right. When you have angles that are like 30 or 40 degrees, things start getting wonky. Like, is that? You can't see it quite as well visually. So be very careful about that and try to work it out on your own if you can. Other things, we can see that we have our frictional force being applied right here and right here. We have our coefficients of friction that were given to us. Now those are parallel to the surface and they're pointing backwards because we're pushing our wedge forward. Our normal forces are always normal to the surface that they're applied on, which means 90 degrees. So that's a 90-degree angle from here. Okay, and over here, like always, our frictional force switches direction when we go from one free body diagram to another if they're connected on that surface. 15-degree angle, we take it from our wedge. And so we have this frictional force reversed here, okay? It's going to the left on this free body diagram. It's going to the right over here. And then we have this frictional force right here, which is pointing down. Why? Because we're trying to lift B. We're applying a load to lift it. If it's lifting, it does not want to do that. The friction isn't like that, so it's holding it back. Okay? So this is the best way to go about drawing your free body diagrams. Start with the wedge that's by itself, the one that you're applying the force to move or keep from moving, and figure everything else out from there. Okay, now equations of equilibrium on B. Why B? Well, I've got 1, 2, 3, 4 unknowns, or do I? There's 4 equations, or sorry. I've got frictional force here and force D here, but those are connected by frictional equations. So you see that F is directly related to N, and FD is directly related to ND. So in the end, if I know N and I know ND, I know F and FD. So I actually only need 2 equations to solve this. So some of the forces in the X direction and some of the forces in the Y direction. Now this is where it always gets tricky. Some people forget that this normal force right here has both an X and a Y component. You can't forget that. So let's work those out. Which one is which? It's kind of hard to see, so I'm going to draw it a bit bigger. This is N right here. And it's going to have an NX component and an NY component. Right here, NY, NX, and this is N. Our angle is 15 degrees. It's going to be here. Okay, and depending on where we choose our angle, that's going to determine what trig function we use. So if I want the y component, well, that is adjacent to my 15-degree angle. Adjacent over hypotenuse is cosine of 15. And we see that right here. The second one is going to be the x component, and that is opposite my 15-degree angle. So opposite over hypotenuse is sine. So in the x components would be sine of 15 degrees. Now we can do something very similar for our frictional force, where we're breaking that up into components. And once again, if you're struggling to see it on the little 3x diagram, draw it huge. Draw it huge, and that will probably help you. Okay, got my y component here. So I'm just going to say force y, force x, and the frictional force F. And then we know our 15-degree angle is over here. It's on the small side. So adjacent over hypotenuse to get that x component. So that would be cosine of 15. You see that right here. Opposite over hypotenuse to get our y component. So that would be sine of 15, which is what we see right here, with the 0.4n being our frictional equation. So from this, we instantly get what N and Nd are. We can get these normal forces. Then we can begin to plug those into our other equations of equilibrium. So, for example, right here, we need to figure out what Nc is, and with that, we can then finally calculate our force P. So, if we look at this, we can fill in our frictional force here. We know N, so there's only two unknowns, 3 equations. We've got plenty of room here. So let's go ahead and solve. So some forces in the y direction, well, that's pretty easy on this one. N has both a y and an x component, as does this frictional force. So we break it up similarly to how we did earlier. Our x components, we have force P, we have our frictional force at C, and we also have x components from both our normal and frictional forces. So we break it up just like we did earlier. With that, we get that our NC is 3,868 pounds, and P is 4,054 pounds. And notice this, we didn't even have to do any algebra for this one, which is why you should always be very careful when you're looking at it, because this is only in the x direction. So with my unknowns, I can solve for NC in the y direction. So use that to your advantage. Help yourself out by doing the equations in the right order. Okay, that's everything for this one. I hope it helped you, and I'll see all of you next time. Bye-bye.